Hi, folks. So as Liz just said, there've been a number of talks today that I'm jumping up and down, I can tell you the answers for them. So earlier, Sarah Novotny mentioned about the risks of what open source you're using, how well maintained they are, things like that. We earlier had Kate talking about S-bombs, which is also in here, similarly with Adrian's talk. So my name's Jamie. My pronouns are he, him. I'm not wearing a t-shirt today, but I'll be wearing it tomorrow, which has my website on it. My website is a big part of my personal brand. And I also have an elsewhere page. So instead of listing the dozens of social networks that we have now, there's one page you can go to, and you can find me everywhere. I have, over the last few years, been drawn towards engineering enablement, developer productivity. And I'm currently at Elastic working on developer experience. The reason I mentioned that I was previously at Deliveroo will become apparent in a few minutes. So over the last few years, I have been looking at understanding open source. So right now, I'm giving this talk. The first time I talked about this was last year in July. Just celebrated the anniversary of the project itself. So it's only a year old, but in that year, so much has happened. Every time I've talked about the project publicly, I've had to redo loads of the slides, which is a really nice experience to constantly be breaking stuff for myself. And in August 2022 was the first iteration of understanding dependencies. And this was where I was at Deliveroo, and I was working using the Dependabot APIs. In 2019 was the first public thing I've written about this whole process and trying to understand how open source packages are used in the organization. And then in 2017, I was writing horrible shell scripts to sed and grep things out of Gradle and Maven build files that was very painful but kind of worked. So why is it actually important to understand how open source and things are used in your organization or your open source projects? So I'd love to just quote the first few lines of this blog post. I won't. But I was very happy when, every time I've read it since, I'm really happy with how I've summed it up. But so in recent years, it's become unavoidable to build on top of open source. And I guarantee there are no businesses that could start now that could just build things from scratch. There's so much stuff that you have to do that you're going to need to rely on someone else having done a lot of the work for you. It also means that you can reduce the amount of domain expertise you need in all of the things, and you can instead just focus on the things that actually matter and are actually the important things for what you're trying to do. And it's also good because there's a bit of free labor. There are other people doing the work to fix bugs, to improve and add new features, as well as your own engineers doing work as well. And open source is great, but it's not always sunshine and rainbows, because as the pivotal XKCD dependency is about, there's not always smooth sailing. There is someone, at the end of the day, most likely doing free work for you, who has a life and doesn't want to constantly be berated by you. There was a mention earlier of a blog post called "I'm Not Your Supplier," which is very interesting. And with lots of people talking about the supply chain security toolkit, supply chain security, it's well, some people are just throwing some cool code up there because it scratched their itch, and they want to share that with people. And now they've got $1 billion company requiring them to do S-bombs and all sorts of other stuff and jump through hoops. And why haven't you fixed this bug yet? And it's this is my free time. Pay me. And then some people don't want to get paid because then there's expectations, or you may live in, as Terence mentioned earlier, a spicy country where you can't actually pay someone. As well as that, so there are also cases where open source libraries have been yanked from the public. For instance, in political protest, there have also been widely deployed open source libraries, like Log4j, that had the Log4Shell incident a few years ago. I think the industry is still finding users usages of Log4j at vulnerable versions in production systems, which is terrifying. But also, like, it happens. And it's also really important to like know how much open source you're using, because you need to like say nice things to the people who are doing it. Like, again, a couple of people today have said, like, just go up and say hi, say thank you. Like, it does mean the world. And most of the time, like, the interaction a maintainer has is, hey, something's gone wrong, or why doesn't it just do this? And just saying thanks, like, will honestly make someone's day. So yeah, like, do you fully appreciate the dependency you have on your supply chain? Probably not, because there's a load of things in there. And so being able to understand how your business uses open source is really important for a few other key reasons. So how am I affected by that dependency migrating away from open source? So as I mentioned, I work at Elastic, so I know you're probably thinking that. But in the last few years, there have been loads of different companies who have done similar, where they've migrated their project from open source to not. And trying to understand like how that affects you as a company, as a project. Like, you kind of need to know that a little bit more easily. You may also have like unwanted libraries. So not necessarily just things like, oh, the license is something that our company doesn't like, but it could be things like, that is built by a competitor, and we do not want to depend on software that our competitor writes because reasons. Or it could even just be things like, we don't really like the style of the library anymore. It's a little bit dated, and now we like to use more idiomatic things, stuff like that. As someone working on like platform tooling, developer experience, it's also really interesting to understand like how different teams use different libraries, frameworks, tools, because you may find out that, oh, we thought everyone's using this one framework, but actually we have 12 different frameworks being used, and oh God, we now have to support all of them. And similarly, like, being able to understand what unmaintained, deprecated, or vulnerable pieces of software you're currently relying on is also really important, because you need to know those sorts of things to be able to like make the informed decision of, do we need to migrate? Do we need to fork it? Do we need to just throw our hands up in the air and call quits? Stuff like that. And this isn't a repeat slide, but as well as like your business understanding open source, you also need to understand like your internal source code. So I guarantee that as a company, you will have built some internal software libraries that you rely on. A number of those are going to be vulnerable to security issues. They're going to have issues of like, they haven't been maintained in a while. They're getting a bit rough around the edges. And yeah, it's all well and good like just looking at the open source stuff, but there's also all the business specific things. So like, I worked at companies where there's a security library that hasn't been updated in quite some time. And there are teams who are still on like very old versions. And it's things like that that if you can actually understand these sorts of things, you can make that informed decision and work out where you need to improve things. As well as all those great sounding things, you can also add other insights like, how maintained is this dependency? Like, how frequently a release is getting pushed? Has the maintainer actually like touched the project in the last 2 years? Is there a community around it? Also things like, do the maintainers follow best practices around supply chain security? Are they just like YOLOing changes into their main branch? Or are they actually following like code review? Do they have multiple contributors, maintainers, committers? Or is it just one person on their own shipping very critical software? And also, like, how many of your dependencies are actively seeking financial funding? As I mentioned, like, not everyone wants it, not everyone needs it, but it is nice to know because it is good to give back. And at least knowing, like, all of these places are saying they are set up to receive funding is a good start than just like, oh yeah, like, it would be nice to give back, but where do we go? So like those all sound like good ideas, but how do we actually do that? So the first thing is you could pay a lot of money to vendors. Like, the list is endless. I kind of feel like I'm a vendor because I've got a t-shirt on for my project. It is an open source project. And so the thing is, we're going to look at this just using open source because like, you have probably all like sat in a room with a vendor, given a sales pitch and saying, well, if you pay us a large amount of money, we will solve this for you. Or if you produce an SBOM, this will magically be fixed. And it's not true. Like, there are things that get you to that point, but you don't need to pay someone to do that. There is open source. There are lots of open APIs and open API for open APIs. Yeah, so this is where dependency management data, which is a project I've been working on for the last year, comes in. So the URL is dmd.tanna.dev. I am not good at naming, so dependency management data kind of explains what it is, but also doesn't. And it's a massive mouthful, and I sometimes regret it, but oh well. So dependency management data, like the most important thing is an SQLite database. So it gives you database access to all of your dependencies and information around them, so you can start querying them. There are other ways of interacting with it than just SQL. So if that's not fun, there are other less fun ways of interacting with it as well. To actually get there, there's also a command line tool which takes a load of data, spits out that SQLite database, and you can then do more things with it. There's also a web application which, among other things, has a GraphQL API that can be independently deployed. And then because you have this database, you can integrate it with whatever you want. You can give it a database browser. I know someone who is deploying it with some other software, so they're integrating it into their own tooling. So yeah, SQLite was like a really important first choice because it's so convenient. It's a single file database. You don't have to worry about having Postgres at a specific version installed on your local machine and wherever you're deploying it to. Like, you have one file, you can just send it over on Slack. Like, it's the first way of working around with this. I was literally like slacking people the database, and that was fine. Like, wasn't as good as it could be, but it is super convenient. And it's great for like local only testing and building applications on top of it because you don't have like a long running server that you need to manage and maintain. And one of the key decisions I made around this was treat that as like a immutable throwaway database. So instead of trying to worry about doing like database migrations, I was like, I'm not even going to do that. We can just skip that by saying it's immutable, and then, yeah, makes it easier. And then another key thing was, like, vendor lock-in is awful. So the idea is you use the dependency management data, CLI, DMD, and then after that, that database is yours to do with whatever. So you don't have to use any of the tooling once you've ingested that. And like the schemas are all open and able to like understand. It's not all obfuscated. So it's straightforward for people to use. So the CLI itself, as mentioned, it creates that database by ingesting different sources of data, which we'll talk about in a little bit. With that raw data, you can then enrich it with even more data to give you more insight into your data. I'm saying data so much. So those are called advisories or dependency health. Again, we'll talk about that a little bit more later. You can also get your own views of the data using custom advisories or policies to say things like, this internal library should not be used because it's got a security issue, or we don't like using vendor software, or the US government has banned this piece of software, so we cannot have it anywhere in our organization. And then some of the really common things you're going to want to query for the data is also, there are these open source reports that present that to you. So this web app is quite useful because it's centrally deployable and accessible. So for instance, behind your VPN, which means you can share URLs with colleagues. So you can, for instance, like look at reports, or you can use the dataset open source project, which is a really powerful SQLite UI. And you can like write a 300-line horrible SQL query And instead of sending that query to someone and saying, can you go and run this, you can just send the URL of the deployed web app to that person. And even though it's a long URL, they don't have to worry about writing that SQL out and trying to read what it is. They just get that data. As mentioned, there's also a GraphQL API, which can be used to integrate it with other services. And it's very useful when it's deployed. So anyone in the organization can have a look. There's also a separate CLI, which is just the GraphQL API. That makes it really useful to deploy that on its own for consumption by services, whereas the main web app is more like user-focused. So how did I actually get to doing this? So this was a post from 2019 where one of my colleagues at Capital One, where I was working at the time, had started working on a side project to understand dependency trees. And the idea of it was to look at, like, when do we have dependency updates to do? We were on GitHub Enterprise, self-managed, so we didn't have Dependabot enabled at the time, and we were just rolling out mend renovate, at which point this side project was basically defunct. And talking with my colleague, I was like, well, it may be interesting to be able to say, like, these are all our dependencies, let's go and fund them. Like, now we know how many people use, say, JUnit as a testing framework. Let's send them, like, a proportional amount of money that actually helps that. And that kind of bubbled away a little bit. And then in August, a couple of years ago, I joined Deliveroo. And as a big proponent of open source and giving back and Hacktoberfest, I wanted to try and drum up more support and more interest. And so one of the questions I kept getting was, well, what should I contribute to? Which is a very hard question to answer. And so Deliveroo was a data-driven organization, so I was like, okay, let me get some data together. So I took the Dependabot APIs and scraped them and got some idea of what our most used packages were, just as like a starting point. And it was fine, but it missed out on a load of ecosystems we used. So we had a load of Scala applications, which meant that, yeah, we just didn't have that data. But it was fine for Hacktoberfesty things. And also, like, it didn't give specific version numbers. It was often just like version constraints, which were very annoying to work with. But as I say, it was fine. But once we had that data, like, I kept trying to use it for things. And it turns out it wasn't just like a one-trick pony. There's a time where we had a Datadog SDK upgrade that we needed to do. And I was like, oh, well, I have data around all the people using the Datadog SDK, and was able to query that, and we were able to say, oh, actually, we only have like 3 teams that need to do any work. And it was through like realizing that, like, kind of unlocked a few things, and I was like, this is interesting. At the time at Deliveroo, we then rolled out Mend Renovate, and as part of that, there was so much more data, so much more useful and actionable stuff. That then led me to find the site endoflife.date, which if you haven't seen it is excellent. And it gives you interesting things like the version of Node.js 12 has been end of life for however many days. And it's an open API, it's very useful. And I was starting to write an integration at Deliveroo to do this, where it would take our dependency data and flag up things like end of life usage. And I was like, whoa. This doesn't seem like something that is just a Deliveroo thing. Like, this is something that can benefit a lot of people. So as it was an evenings and weekends project that I was passionate about, and as it was a clean room implementation, I started off as an open source project. And over like the last year, I've built a load of things, and it's in use in different places than just Deliveroo, and like that's really nice. That I didn't have to try and rebuild it at the next company. I could just take this open source project that keeps on growing. So how does it work? This is like the TLDR getting started guide. It's basically like 3 commands. So first you need to get some data somehow. So we use a package of mine called Renovate Graph. Then you create the database. you import the data, and technically that's all you need to do. At that point, you then have all the dependency data and you can start running queries. You may also want to generate additional data like advisories to say this has a CVE or this is unmaintained, but off the back of it, you can just do it with the plain data, and that's what it was for some time. So grabbing like different things of data is quite important. So as mentioned, there's Renovate Graph, which uses Renovate, the dependency management tool, because it just supports so many things. And I found a way to like write a really small shim over it just to export that package data it understands, which I've also converted that to an SBOM, which is also somewhat useful. But it doesn't require you to be using Renovate already. You can use this alongside whatever other tools you've got. You can also use just plain Dependabot APIs, which uses GitHub's SBOMs API. You can also consume SBOMs from whatever other tooling you're using. So you don't need to onboard another thing to get some data out. And I've also got another tool which is used for more things like infrastructure. So for instance, you can scan a load of AWS infrastructure and see, ooh, in the next month, we will have to do some Lambda runtime upgrades, things like that. And there is scope for lots more. When you're importing that data, basically takes a well-defined form, converts it to an internal model, and then uses that for future. And then you can write SQL to basically answer any of the questions you want. So you can do things like which repos in our organization are running a vulnerable version of Log4j? How many repos are using a version of the Datadog SDK that's older than whatever? What's our most used transitive dependency or direct dependency? So as mentioned, there's a number of like inbuilt reports. So this is just the output, the help command. So there's a few things that you're probably going to want to do a few times, like list the things that have advisories, or give me a list of all the places that are dependent on this package. So say, for instance, you want to find out where are we using any of the HashiCorp products. You can just plug that into there, and then you get a list of all the repos that are depending on it. The advisories, I've kind of touched upon it. So when you've got just the base raw dependency data, you can ask things like, what Terraform modules and versions are we using? Or which teams are using the Gin Web framework or Spring Boot? But it would be much more useful to be able to ask things like, are any of our projects relying on libraries that are no longer recommended by like our Go or Java language guilds? Or how much time should my teams be spending over the next quarter upgrading AWS infrastructure? Things like that, which requires more data. Like you can't do that just off the bat. So in come a few different APIs. So there's endoflife.date, there's deps.dev, and ecosystems, which are all open APIs. You can use them to your heart's content, and they provide a lot of really useful insight into lots of different things. There is also the end-of-life checker that I mentioned, which has a load of AWS specific and other infrastructure-y things that can be useful. But for a lot of these things, like it's taking external packages, but often you have internal packages that like you can't query some public API to say, should I be using this internal thing? So this is where custom advisories come in. And you can do things like write this SQL query or SQL statement to define your own reasoning for why not to use packages. And this can source things like, this has a security vulnerability, this isn't maintained anymore by the internal team, stuff like that. A slightly more complex way of writing that, because not everyone wants to write like SQL like that. It has like some quite fun like conditional statements when it's doing the querying, which looks kind of horrible. So instead, there's this thing called policies, which uses the excellent open source project Open Policy Agent, which has a policy language called Rego. And this allows you to write fairly readable things like this, where you can say, if any of my packages are referencing the old GitLab server that we used to use, flag it up as that package is no longer maintained. And this then surfaces to teams that they shouldn't use that. Similarly, you can do slightly more complex things where you can look at the exact version numbers that are in use in your projects and flag up things like that. As well as this, it's quite useful to be able to know these things, but you also probably want to be able to say who actually owns this service that is running horribly outdated production software. We should get in touch with them. So as part of this, there's also ownership data. So within here, you can insert it from whatever service catalog or platform you're using, including spreadsheets. And from there, you can then add that data into your queries, and you can surface who owns that. As well as just who owns a thing, it can be quite useful to be able to say things like, which of our customer-facing services are using an outdated version of the thing. So this repository metadata allows you to add things like additional context to all the repositories that you have in your organization, which then lets you write a slightly garish query like this, which lets you add that additional context and do some more stuff. There's an example project which has a load of public code ingested into it and constantly running that data. There's also a contrib project where a lot of shared custom advisories are there. So just the last section I want to go through is 5 minutes. Okay. Are some case studies. So these are all written out in full on the documentation site. Okay. My slides haven't shown up properly. So you can do things like, give me a list of all the advisories that we have. But there's a slightly more interesting one. At Deliveroo, we were in an incident where we found a race condition that was due to a transitive dependency in how we were using it. And the team that had managed the Kafka sidecar that this was in had already released a fix for it. But not all the teams were updated. And so we had to convert data from this YAML file, which isn't super searchable if you don't have it all ingested nicely. But luckily we did. We had ingested it via Renovate, and so we had dependency data to say, these are all the versions of the sidecars, and we're able to take that and say, okay, which teams are going to need to update that, because we really need to update it before the end of the day. We could also prioritize the actual important business services by taking things from our service catalog and writing this even more complex query, which basically allowed us to get that data. We're able to see, okay, there are 2 teams that are affected, and here is the owner of one of them, and they're ordered by the business priority. Similarly, with things like log4shell, there's actually various ways you could get around this. So you could use the dependent on query that I mentioned before. You can just write some SQL. You can write a slightly longer SQL query to look at the different versions that are affected. Or using the Open Policy Agent integration, you can write a slightly more readable version which actually looks at the dependency data that comes in. You can do queries that actually pick up the right things. And this sort of organizational policy can make it really nice to codify some of those things and then get them flagged up. I'm going to skip this one. Something that a load of folks found they were potentially going to be affected by was Docker changing the way that free tier worked. And so being able to understand which namespaces on the Docker Hub you depended on was quite useful. So inbuilt query, if you have that data, it is really straightforward to get that out. Often the problem is getting that data and getting started. So as mentioned, the getting started is 3 lines. Naturally, there's more to it than that, and there's a load of things happening behind the scenes to get that data out, but you effectively can just do this. And yeah, so last slide, load of links. I have written up this talk as a blog post, so if you want to review it, feel free. And yeah, I was going to say for questions, I'm happy to answer them after. Yeah, thank you.